Hello and welcome. This is a further Pure 1 exam. Okay, this is June 2015. Now, this is obviously question 1. I think I haven't really said that. I'm losing the will to live at this point. Anyway, okay, so we're told that this is function of x, which is 9x cubed take 55x squared. 9x cubed take 33x squared minus 55x take 25. And in a little paragraph below, it says, given that x equals 5 is a solution of the equation of fx equals 0, so in other words, this equation equal to 0, which I'll put that one, okay. Use an algebraic method to solve fx equals 0 completely. In other words, this is just a solve an equation equal to 0 method. Now, there's a few things I want to point out here. The first thing that we're told, x equals 5 is a solution of the equation. In other words, so if x equals 5 is a solution of the equation, that means f of 5 is equal to 0. In other words, there's a factor of this. Factor is x take 5. Okay? And that's a factor of that cubic. We're also told, or whatever you want to put it, we've got to use an algebraic method to solve fx. Now, it doesn't say any specific algebraic method. It doesn't say, just trying to think, the Rapson process or Newton-Raphson process, right? Now, there's a very good reason for that. Well, let's think about the equation, the ways of solving an equation that we've looked at in FP1. Well, obviously you've got the bisection method. Well, no, because it's not giving us an interval. Okay, we need an interval, and you don't have time to do it. Therefore, it's also not told us any linear interpolation where we've got to do them similar shapes thing, because there's no limits. We need the same principle of giving us an interval. And obviously, well, you go, well, therefore the other equation we could use is the Newton-Raphson process. Well, we've not got the starting xn, if you want to call it that. Okay, so we can't use that. So it looks like we can't use anything. But the really key thing to point out here is this, that given x equals 5 is a solution of the equation. And that we need to solve it algebraically. So that just means to some algebraic method. Okay, so it's very loose in terms of what method it's telling us to use, and really that should have not been a problem when you saw that x equals 5 as a solution. So well, x 5 therefore it's a factor, and we can use any algebraic method. It doesn't say what specific type, and the only one we can really use is algebraic long division. If we know that x equals 5 is a solution, if we divide this cubic, okay, or this function of x by x take 5, we should get an answer of 0, but with the quotient, the bit on top of the little bus station sign, should is our quotient, okay, and that times x take 5 will give us this cubic. In other words, x take 5 is a factor, so therefore the other factor must be a quadratic, okay, which we're going to, it solves completely, so we need 3 linear factors, in other words. But that's going to be a little bit tricky as we find out. Anyway, so let's just do what I said. So x take 5 is a factor, so we divide this cubic, this 9x cubed, take 33x squared, take 55x, take 25, by x take 5. Now, hopefully you're all fairly familiar with algebraic long division. Now, I'm hoping, as I said that because, well, it's the exam, you're looking at the exam, so hopefully you've done the topic. Anyway, okay, so it's 9x cubed over x, okay? In other words, the first part of the quotient is 9x squared. Now, you might have spotted that straight away, that's the first bit of the quotient, but this is the way to do it, okay? So anyway, you divide, you get 9x squared, you times x take 5 by 9x squared, which obviously gets you 9x cubed, take 45x squared, and you're taking that away from the cubic, okay? So obviously it's not going to give us an answer of 0 yet, so we have to do it all again. Well, quite clearly, sorry, 9x squared, the 9x cubed cancel. So in other words, it's I need to take that away. So it's minus 33x squared minus 45x squared. In other words, obviously it's going to give us positive 12x squared. Now you might want to write it up to you if you put plus 0x plus 0. That only really applies if we're doing 9x cubed take 55x, because obviously you might end up taking the x squared away from the x. But so that doesn't apply in this case. And if that's just something to confuse you, don't forget I said it. Anyway, so we're left with this 12x squared, okay, and then the minus 55x minus 25 hasn't changed. Okay, so same principle again. We divide 12x squared by x, okay, which obviously gets us plus 12x. And we're timesing that by x take 5. Well, that obviously gets us 12x squared, and then when we times 12 by 5, obviously we get 60, but it's minus 60x, okay? And you're taking away 12x squared minus 60x away from this 12x squared take 55x take 25, okay? But obviously that doesn't come to 0, so we have to do it yet again. Okay, so obviously, so the 12x squared cancel. Then you're left with 5x minus 25. Okay, so do the same principle. 5x over 5, 5x over x, sorry, which obviously gets you plus 5 on the quotient here. Alright, and obviously on the bottom here we're left with 5x take 25. And obviously when you take them two away from each other, it equals 0. And if it didn't equal 0, that means x take 5 isn't a factor. Now if it didn't tell you that x equals 5 was a solution, then what you do is you do f of 1, f of 2, f of 3, etc, etc, keep going up. And obviously do the negative version as well. Until you got an answer of 0. And when you got an answer of 0, that is a factor, okay? That is a solution. So you do the same principle. They've just told us one of the solutions. They might not have said x equals 5 is a solution. They could have just said, given you that cubic and said factorise it completely. Which is what you would have done is say f equals 1, f of 2, f of 3, f of 4. Keep summing in integers to get it equals 0, excuse me. Okay, so anyway, what we're saying here is 9x squared plus 12x plus 5 times x take 5 will give us this cubic. Okay, so we know that they're equal. Okay, so but it asks us to solve it completely. So in other words, we need to factorise this quadratic. Now we'll just write out where we are so far because you just need to picture it, okay? So, squared plus 12x plus 5, that's equal to this cubic. So 9x cubed, take 33x squared, take 55x, take 25. Okay, so I don't know about you, but I'm no genius. But anyway, that's not the point in seeing you are. So, okay, I really am crap at factorising quadratics, but even the genius inside me can see that's not going to factorise quite so easily. Because all we can really times to get 9 and 1, okay? But as whole integer powers, obviously you could times 9 over 2 by 2, but in terms of positive integers. Okay, however, what we've got here is a situation where it doesn't look like we can factorise it, but obviously we can. So it's a simple case now of just using the quadratic formula, okay? So even though, you know, A-level further maths, I still always like to label what I mean by A, B, C, okay? So obviously our A is 9, B is 12, and C is 5. Now, maybe that's just me being a little kid, but I don't really care. So anyway, going on with this quadratic formula. Now, bear in mind, we are in, weirdly enough, further maths. And in further maths, it generally is, somewhere in the first few questions, something to do with complex numbers. Now, you have to bear in mind, complex numbers kind of arise from this quadratic. That's why we introduce them, so we can factorise all the quadratics. Anyway, so it's minus b, so it's minus 12, plus or minus square root of b squared, 144, take 4 times 9 times 5. Okay, it's all over 2a. A obviously being 9, so it's all over 18. Okay, so obviously what you want to do is work out the square root. But you'll find it comes to the square root of minus 36, which we know, obviously you can't do that if you put it in your calculator, but you should know that we can break it up into root minus 1 times root 36. And that obviously comes because the imaginary number I is equal to root minus 1. So it's I times root 36. In other words, I times 6 or 6I. So we can replace that whole square root with 6I. Okay, so what we've got here is a situation where it says x is equal to minus 12 plus or minus 6I over 18. But you can quite clearly, if you put 12, imagine that was 6x for example, obviously you could still factorise it down in terms of you could still simplify it to 2/3. So you could simplify that to minus 2/3 plus or minus 1/3 I. Okay, so obviously one value of x be minus 2/3 plus or minus, plus I over 3 or 1/3 I. And obviously your other x value would be minus 2/3 minus 1/3 I. However, there are two values of x that we found simply from working out this quadratic here. So they all them two values just simply come from that quadratic. But you can't ignore the fact they've already told you. They're not saying what are the other factors, they're saying factorise it completely. Okay? In other words, you have to use the value they've already given you. Now, they want us to factorise it completely. Okay? So we know these are our values for x, okay? But we also know from earlier on in the question that x is equal to 5. But it wants us to solve x completely, So all we need to do is state these two values of x and the value of x it already gave us, so x equals 5. Okay, so then you do another line saying x is either equal to 5 minus 2/3 plus 1/3 I, and minus 2/3 minus 1/3 I. So there are your three solutions. It's kind of crucial, and it was a common mistake that people forgot to put this x equals 5 because, well, you were given it in the question, so why would you put it as an answer? Well, the reason for that is that they're not saying not do that, and they're saying solve it completely. Okay, so that implies they've already partially solved it for you. Well, maybe not, but you get the idea. Okay, so that was just really a case of reading the question. If you missed off that x equals 5, I probably would have imagined you just at least only lost a mark, which isn't too bad in the grand scheme of things, considering this was, how much was this worth? I can't remember. Oh, it's worth 5 marks, so you would have lost a mark not for including that x equals 5. Okay? But as I said, it is quite a weird one because it's not something you would expect a question in FP1 to be. As I said, it's not been a specific topic in FP1. It says it's more of a C2 topic, or a C2. But you can see the reason it is in FP1 is because we've got this imaginary number business here. Okay? So thanks for watching. Hopefully it's been helpful, and we'll see you in question 2.